In the last lesson, we managed to get our minted NFT to show up on our front-end website. That NFT, however, was minted through the command line. So we basically initialized a new canister and passing in a bunch of inputs that resulted in this NFT. Now, we want to be able to let our users mint their own images, to upload images, and then to create these canisters programmatically and to be able to mint them on the fly. So that's what we're going to be tackling in this lesson. The first thing is we're going to be working on this minter.jsx. So at the moment, it's just got some plain HTML, and we want to be able to show that through our app.jsx. So I'm going to go ahead and comment out my item here, and instead, in between the header and footer, I'm going to add the minter. So again, selecting it from the drop down, it'll auto import it at the top, and then we're going to set this as a self-closing tag, as with all our React components. And let's hit save and just see what it looks like. This is a very simple form with basically just two fields. We've got an upload image where we can click on this button, it'll bring up our Finder, and you'll be able to choose an image to upload. Now we've also got this section where we can add our collection name and collection number and whatever it is you want to show up as the title of the NFT. And then we've got this little button here, which once we click it, should trigger all of the background stuff and get our NFT minted and our canister created. So this is what it looks like right now. The first thing we want to do is to be able to pull in all of the information that's entered into this form right here. You'll notice that we've got our two inputs here, our input for uploading and our input for the name. Now the name is a lot easier, so let's work on that first. Whereas normally we would use our value and our onChange attributes here in order to statefully keep track of what's entered into the input. In this case, we're actually going to use something a little bit different. And we're going to use something called useForm, which comes from a module that we installed called the React Hook Form. And this is a really nice way of pulling in data that's been uploaded or entered into a form. To begin, let's go ahead and register the form, and we do it in a very similar way to how we would use our useState. So we create a new constant, but instead of opening up square brackets, we're going to open up curly braces. The first component is going to be called register, and this is going to be an object that we can tap into in order to register and add in all of the inputs that the user create on our form. And then the second input is the action, right? So this one is going to be the handle submit. Basically, it's going to be the function that's going to be called when the submit button gets triggered. And we're going to set it equal to useForm. Now, useForm is not one of the native React hooks, so we actually have to import it. So we're going to say import, and then we're going to open up a set of curly braces, useForm, and we're going to import it from our React-hook-form. So now we can use form, and we're going to initialize it to empty. So now comes to the stage where we actually register our inputs. Right over here where we have our inputs, we can add another line by hitting enter, and we're going to add to the objects that are already registered. So we're going to use that triple dot notation that you've seen before in our JavaScript lessons. And I'm going to add to that register object, and then I'm going to give it a name so that we can identify it later on. And this I'm going to call the name. And then after that, we can add some options. And I'm going to add a required option, and I'm going to set that to true. This way, it makes sure that users will actually enter something into here instead of leaving it blank. So now that we've registered this name, we've got to trigger the handle submit at some point in our code. And in our code, we've got this mint NFT button, which is actually formed by a span. We can add an on click to this span in order to make it trigger our handle submit. And let me just make sure that I've actually spelt this correctly. And then inside this method, we pass in the name of a method that we've got that will actually handle the submitting. So I'm going to create a new asynchronous function here, which I'm going to call onSubmit. And this is going to be passed the data from our form. So we can now tell our handle submit that that's the method that you should call and pass in all of the components that were registered into the form data. In terms of the flow of data, first the user types something into this input, which gets registered as an object into all of the data. And then once this button is clicked, then it's going to trigger the handle submit, which comes from our use form hook, and it's going to trigger the onSubmit button, which we've defined here, passing in the data. So now, in order to make sure that this actually works, let's go ahead and console log our data. So we're going to say data dot, and then we're going to give the name that we registered here, which is name, data dot name, and let's go ahead and see what that looks like. Let's hit save and go over here, type something. I'll just type hello, and then click Mint NFT, and you can see what I typed show up down here in the console log. So now that we've made it work for the text input where we enter the name of our collection, let's go ahead and make it work for our upload input as well. So we do basically exactly the same thing. We add to the end of our object through using register, and we give it a name that we'll be able to use it to identify with. And I'm just going to call it image. And I'm going to set the required property to true as well. Both of these will be obligatory inputs. Again, handle submit will call onSubmit, passing in all the data. And if I go ahead and console log the data.image and hit save and go over to here, and if you take a look at the current Udemy lesson, you'll find a download to a collection of CryptoDunks that I've created for you. They're absolutely tiny because they are 20 pixel by 20 pixel large, but we're going to enlarge them on our front end, so you don't have to worry about that. So once you've downloaded and extracted the folder, you'll be able to open it and just choose any one of these to upload. And it doesn't really matter what name I'm going to give it because I'm only logging the image. Now if I click on the button and submit those inputs, then you can see that what gets printed here when I print data.image is a file list, because you can upload multiple files, right? So the first item in our file, the 0th item, is our image, cryptodunk3.png. So that works perfectly. Now let's go ahead and delete our console logs and actually use this data to mint our NFT. First, I'm going to create a new const called name, and I'm going to set it to the data.name, which is what I used to register the contents of that input. And then I'm going to create a new const called image, which is going to be set to data.image. But remember just now how we saw that it was an array. We have to get hold of the first item in that array. So we're going to add the square bracket 0. Because this data.image contains a whole bunch of data that we don't actually want to store on the blockchain, including the file name and file size and all of that metadata, we're going to strip it down into just the bare bones actual byte data so that we can store that data on the blockchain and be able to pull it out and display it. Let's go ahead and create a new constant, which I'm going to call the image byte data. And I'm going to create an array, which is going to be an array of NAT8 numbers, or something that can be converted into NAT8 numbers that we can put in here eventually. In order to do that, we're going to use the 3-dot notation to add to an empty array. And inside here, I'm going to create a new uint8 array. And I'm going to initialize it by calling await, and I'm going to use the image.array buffer. and we end that method call with a set of parentheses. The array buffer object can be used to represent generic binary data, and we're going to store the binary data for our image that's uploaded. We can create it either from scratch or tap into the blob.array buffer. And as it says, it returns a promise, so that's why we need to use the await in front of this. And it basically turns the contents of our blob as binary data into an array buffer containing our binary data. So once we've done that, making sure that there's no typos in that line of code, because it's a bit complex with all of these things. If you want, you can actually split this off into a separate line if it's easier for you to see. So you can say image.arrayBuffer and store that in a const, which we can set as the image array, and we can turn that image array into a uint array and then store it inside this constant, which will be able to match this nat8 array data type. So now all that's left to do is to tap into our backend and actually mint this NFT. You might think that's done through the NFT actor class, but actually we're going to write the code in our main.matoku file, because this is our main backend. This is going to store these NFTs as a hash map. We're going to go via this to programmatically create new canisters and do something similar to what we did in the command line, but from our backend. So a backend to backend kind of interaction. Inside this canister in our main.matoku, we're going to create a new function, and it's going to be a public shared function passing in the message so that we can tap into the message.caller later on. And then this function is going to be called mint. And it's going to need the image data in the format of an array of nat8 numbers. It's really important that you don't just leave it as nat. It has to be nat8 for all our files to be compatible. And then it's also going to take the name of the NFT as well, which is going to come in the format of text. And then once this minting is all done, we're going to asynchronously actually return an output, and the output is going to be the principal of the newly minted canister. We've got some errors here because we're not returning anything yet, and also in order to use this principal type, we have to import it. So let's go ahead and add that to the top here and import this principal type. And now let's actually write the logic for this. Firstly, let's create the owner of the NFT. So we're going to say let owner, and this is going to need to be a principal data type, but we're going to set it equal to the message.caller. So this is why we made this a shared function, so that we can access the identity of the user who called this method. Now, because it's going to be called from the front end over here, when that onSubmit gets triggered, then that means, if you remember from our previous lessons on authentication, if we authenticate the user and log in the user on the front end, then when we trigger this, it will pass in their principal ID. So that is going to be set as the owner of the NFT. Now, we're not going to deal with the authentication because we've covered that extensively before. So this is just going to come in as the anonymous user who has a defined principal, which we're going to set as the owner of the NFT. Now, the next stage is the programmatic creation of our NFT canister. And we're able to do that because we've created it as an actor class. So we can initialize it and then pass in all of the data that it needs in order to hold on to this as a unique token with a unique identifier and all of the image data. In order to initialize that, we have to first import that file. I'm going to say import, and then I'm going to give that file a name, which I'll call the NFT actor class. And we're going to be able to find it by going one step up, so .. and then going into the NFT folder, and then / the NFT file. So now all the errors should disappear because it can actually see that nft.motoko, and we can use it here to initialize it. I'm going to create a new constant called new NFT, and I'm going to set it equal to the NFT actor class dot, and then from that actor class, I'm going to initialize a new NFT, which requires some inputs to be able to be initialized. So at the moment, if you take a look at this, we need to supply the name, the owner, and the content, and I'm going to do it in that order. So the first thing I'm going to supply is the name that gets passed in to this method. Next is the owner, so I'm going to pass in this principal. And finally, it's the content, which is again passed in to this method as the image data. The initialization is going to be asynchronous. So that's why this is telling you that it's going to return asynchronously. As with all of the async method calls, we have to add the keyword await. Now we've managed to get rid of that error, but we've still got an error here because we haven't yet returned, even though we promised to. So let's just silence that error for now by actually getting hold of the principal ID of this newly created canister. Let's create a new constant, which I'm going to call the new NFT principal. And this is going to come from the newly created canister. But at the moment, there's no easy way of getting hold of the canister ID of a newly minted NFT. So the easiest way to do this is to bind the this keyword to this actor class. So this now then represents this entire actor class, and we can create a public query function which is going to allow us to get hold of the canister ID. So I'm going to call it get canister ID and return asynchronously a principal. And what we're going to return is going to be the principal of this actor class, and we can get hold of it through the principal.fromActor method, which is going to take an actor and give you back the principal of that actor. And normally, if this was just an actor, not an actor class, we can actually simply just pass in the name of the actor. But because this expects all of these inputs, by binding it to this, we can simply pass in this actor right here. Now, back over here, we can call await new NFT, which is the newly minted one, and we can call get canister ID to get it back. And we can return that as the output. So now all our errors should be gone, but there's one thing that we still have to think about, which is a more sort of practical component. If you remember, every single time we created a new canister on the actual live internet computer network, we had to allocate it some cycles. And when we create canisters programmatically, like we're doing here, we have to do the same thing. So if we do this on our local host, our local version of DFX, it won't really mind because it's not going to care, because it doesn't actually do the accounting. But once we deploy this live onto the internet computer, we will need to make sure that it gets some cycles in order for it to actually be created on the live network. The way that we can add cycles currently, at least in 2022, is through something called the experimental cycles module. And the way that we do this is simply by writing cycles.add. And hopefully if you manage to select the add method and hit enter, it will automatically import the cycles from the experimental cycles module. Now, the reason why it's experimental is because the team and the people involved in governance for Dfinity haven't actually yet decided how exactly they're going to implement this cycles module in the future. So right now, this is the only way to do it, and it's pretty simple. All you do is you say cycles.add, and then you specify how many cycles you want. Now, it costs 100 billion cycles to create a new canister. And in addition, we're going to give it 500 million cycles in order to keep it up and running. So The final number will look something like this. And once we've added it, then those cycles will come from this main canister and be allocated for the next canister that gets created. We can check this by actually using a debug. So let's go ahead and import the debug module and use the debug show to show how many cycles we had before. So cycles.balance. And let's copy and paste this to add it on the line after we've created the canister. Now that we've created our method and completed it in the main.motoku, let's go ahead and call it and pass in all of the bits and bobs that we've collected from the user's inputs. In order to call the methods from our main, we have to import it. So I'm going to import my canister, which is called OpenD, which is specified in the dfx.json. And then I can add in its location. So it's going to be ... and then one more ... and we should see declarations. And then I'm going to select the OpenD folder, like this. And below all of these lines inside the onSubmit, I'm going to create a const, which is going to hold the new NFT ID. And it's going to come from me calling the await and then the OpenD dot and then the name of our method here, which is called mint, passing in these two pieces of information, image data and the name. So OpenD.mint, and then the first thing is the image. So I'm going to pass in the image byte data, and the second is the name. Now all of our constants are active, and all that's left is to go ahead and console log our new NFT ID. And because it's going to come back as a principal, I'm going to use the toText, which comes from the principal type. So let's go ahead and import that as well. And now, hopefully, if everything works, I should be able to view the cycles being printed over here. And also, once all of that's done and successful, on my front end, on my console, I should see the new NFT's principal ID being printed as well. So let's hit save and let's go ahead and deploy all our changes to our canisters and our front end by going into our README and copying that command line command. So let's go ahead and paste it, and this is going to hopefully update all of our code and make sure that it actually works. So once that's done, let's head over to our front end, choose one of the pictures from our CryptoDunks, give it a name, give it a serial number if you want, and then click Mint. And if we take a look over here, you can see that the first print is how many cycles we had in our balance for our main canister. And then the second print is what's happened to the balance after we've allocated it to this new canister. And you can see it reduced. And on the front end, we've got the canister ID of the new NFT being printed, which means we can actually use that to display the NFT. Because once this is done, we want to be able to show it, right? Otherwise, how would the user know? That means we can tap into our item.jsx and to render it once we're done with creation. So here we can say if the NFT principal, don't worry, we don't have this yet, we're going to create it a little bit later on, is equal to an empty string, well then we're going to return all of this. So going all the way down to the very last closing parentheses and add in our closing brace. But otherwise, namely if it's not an empty string and we've actually given it some value, then we're going to render something else. And the something else is going to come from the README. So if you scroll down in the README, you can look at it through preview. I've got the minter else HTML, which is basically all the HTML that's going to go into the else statement. And I want you to just simply copy and paste it in. Because it's got a whole bunch of class names, I don't want you to type it all out. Now, what we've got here is it's going to change the form from what it was previously into one that just has an H3 with a title that says minted. So to tell them that it was successful. And then inside the second div, which says horizontal center, we're going to render our item. Again, selecting the item from the drop down, hit enter so that it gets imported. And then we're going to close it off as a self-closing tag. And remember that this item that we created here takes an ID as a prop, which accepts a text principal, which if you remember, we already have printed in here. So now all we need to do is to use our React useState hook to create that constant that we specified here, which is the NFT principal, and the set NFT principal, and use state and set it to an empty string to begin with. So when our component minter first loads up, the state of this is going to be an empty string, which means it's going to render our form. But as soon as we've managed to get hold of the ID by calling this minting function, then we can set our NFT principal to the new NFT ID. And we can also use that to pass in as the prop. And we're going to set the ID to the NFT principal. But remember, this has a principal format, so we have to turn it to a text format in order to match with what's expected over here. So similar to what we had previously in our app component. A couple of things are important. Make sure that you've spelt the prop as ID, and make sure that you're passing in the NFT principal, which is set over here. So the NFT principal to text. Now let's hit save and let's try it out. So here's our front end. Let's choose one of the files, give it a name, click mint. And it tells us that nothing was returned from render, which says that a return statement is missing. So let's check our code. And indeed, in our if statement, we've got our return, but in our else, I've actually forgotten this. So there are a lot of potential mistakes. Even when we try to avoid them, sometimes they happen. But it's good to know and see it so that you know what's going on. So let's try that again. And you can see now we've got our minted title, we've got the new NFT showing up, we've got its name and the owner all working correctly. The only thing that's left is to give the user an indication when that NFT is being minted. So ideally, we'd really want a loader in here when that minting process gets triggered. And again, if you head over to the README and scroll down, you should see the loader HTML, which you can copy wholesale, and we're going to be pasting it into our minter. And I want it to show up just above our H3 title here. So inside the div that's got the class name minter container and above the H3, we're going to paste in our div. Now we're going to give this a hidden attribute, and I'm going to set that to called loader hidden, which we're going to use state to keep track of, and the set loader hidden to update its state. Now we're going to start the loader hidden with true so that it doesn't show up. And then as soon as our form is submitted, so they press that button, we're going to set the loader hidden to be false so that the user can see the loader showing up. And then once we've got our new NFT ID back, then we're going to set the loader hidden back to true again so that it disappears off the screen. Now let's try this finally, and you can see the full functionality of our minting process. So let's choose a file, give it a name, And as soon as I click on Mint, you can see our loader show up, which gives the user an indication that something is happening. You don't have to keep pressing. And finally, we get our minted NFT showing up and with all of the canister details being pulled in and displayed through the item component. So now users can actually mint NFTs on the internet computer using our OpenD website. Now, in the next lesson, we're going to figure out how we can display all of these NFTs that we mint in the My NFT section of this website. So for all of that and more, I'll see you there.